Hello, everyone. This is Sebastian Traeger, Managing Director at Reliability Center, and welcome back to another edition of the Reliability 4.0 podcast. As always, we're on a mission to help make the world a more reliable place. And today we are thrilled to be joined by our special guest, Debasmita Mukherjee from Bloom Energy. Debasmita, thank you so much for joining us today. We are just thrilled to have you. Thanks for giving us some of your time.
It's a pleasure, Sebastian. Thank you for inviting me.
Now, you serve as a hardware product reliability manager at Bloom Energy. Tell us a little bit about your role at the company, and then just a little bit more about the company itself.
Sure. So right now, I work as the senior manager of the product reliability team here at Bloom Energy, which is a solid oxide fuel cell-based power generation company. Prior to Bloom, I worked as a reliability engineer in Rivian, which is an electric vehicle company.
Mm-hmm.
And basically, our mission in both the companies is clean tech reliability. So essentially, at Bloom Energy, we provide power generation solution to the customers in a much more cleaner and sustainable way. And at Rivian, we were downstream. So essentially, we were serving the downstream users of energy, which is the electric vehicle in the transportation sector, to provide their transportation in a much more sustainable and cleaner way. And reliability, what I have found, is like in the heart. It's like in the gene of both these companies, because it's something which is ingrained. And for a product to be successful, particularly for hardware products, reliability is like it has to be in your genes. And both of these companies, they look at reliability in a similar way. As such, it is built into the product design phase. From there, we go into we're working very closely with our development teams. We will be focusing on reliability from the get-go, to make sure that the solutions that we design for our customers, it's actually meeting their requirements. So, yeah.
That's great. Well, we're going to drill down a lot more into that, but kind of before we get into some of that, just a little bit more about you. So give us your origin story. How did you end up in reliability engineering?
So that's an interesting question. So basically, I'm born and raised in India. I did my bachelor's in chemical engineering from Jadavpur University in Kolkata, India. And after that, I joined a company called Ernst & Young.
Okay.
And it's like it's an audit or a consultancy firm. But my role was in climate change sustainability consulting. So from very early stage in my professional career, I got introduced to clean tech and sustainability. And I worked in India in the clean tech and sustainability field for 6 years. After that, I decided that I should pursue a higher degree, and I came to the US for Master's in Chemical Engineering from San Jose State University in the Bay Area. And while I was doing my Master's, I started my internship at Bloom Energy in the hardware product reliability team. And because my course was in chemical engineering, I could relate to the technology, the solid oxide fuel cell technology, because that is like my specialization also in my master's. So I was very interested. And the reason I got drawn to reliability was the flexibility of how this field of reliability engineering is actually transferable from technology to technology. Right. It doesn't matter, right? Because the success mantra of any product technology, hardware product, is transferable to companies and companies.
Right.
And I was thrilled. And also because, particularly when you're dealing with hardware product, you understand that it's so important to do a deeper dive, understand what the problem is, and then, come up with temporary solutions and then permanent corrective actions, which I'm sure we will talk about in details. But that's how I was in reliability. I worked at Bloom for 7-8 years. Then I moved to Rivian for about a year. Again, exceptionally good reliability experience and good companies to work for. And then I again rejoined back at Bloom last year to lead the product reliability team. Yeah.
Fantastic. I really like that, how yeah, it was really the way it could work across industries that really drew you to it. You're just like, hey, if I understand this way of thinking, I can apply this in almost any arena, clean tech or downstream, et cetera, and go from there. So that's great.
And I think to me, when I see reliability improvement of product over time, that's the success story. Because we did something, we found a problem, we worked with development teams, and we provided a solution. And that got implemented, and we are tracking it for continuous monitoring. And then you see an improvement in reliability and performance. And that's the success that makes us happy and going.
That's great. And then just again, before we dive back into reliability engineering, what do you like to do outside of work? What's a little human interest element of you?
Traveling. I love to
Okay.
travel. Yes.
And anywhere in particular that's been a great trip you've been on?
That's a great question. So I actually went to Hawaii twice, and I find that really relaxing. So that's good. But this year, I am interested in road trips.
Okay.
So I'm thinking of, maybe a road trip to Seattle, have a halt in Portland. So like across the country roads of US, how would that be?
Great.
So,
well, you're in Northern California, so if you haven't already gone on a road trip to Yosemite National Park, you need to make that very high on your list. It's incredible.
It's done.
It's amazing.
Yes.
So yeah,
Amazing.
it's fantastic.
Yes.
Well, great. Well, great to get to know you a little bit there. So let's dive back in. So as you mentioned, reliability is in your genes. It's built into the kind of product design phase. So how does that relate to kind of some of the KPIs that you have? I like to talk to folks about what their goals are and how they set them. How do you all do that in that product design phase? How do you make sure even those metrics are built in to that design phase?
Sure. That's a great question. So essentially, the way I look at it is when we are designing a product, right, there are typical success metrics in terms of performance, right? So be it, if to give you an example, if it is, say, a power generation company, how much power it is producing over life, that could be a success metric, right? But at the same time, there are some organizational guardrail metrics or trade-offs, right? Say, for example, a particular product might result in some cost savings, but at the same time, there could be some hurt in performance down the line. So when we look at KPIs, my goal is always to have an overall performance metric, which will include the key performance metrics, success metrics, but also look into the guardrail metric, which should not be impacted for initial gains. That's something which we always keep in mind.
Okay, so you're trying to balance those, and so you're saying even at the design phase, you're taking those into account and starting to think like how are these going to impact performance over time?
Mm-hmm. Yes. And then we also, like, say, for example, if a new design or feature is introduced, we make sure that it is monitored over time in the actual performance.
Great.
And how is it performing over time?
So what right now would you say are top challenges or priorities that you have? I mean, I know some of the work you do, obviously you can't speak in detail about, but to the extent you can, what are some of the challenges that you're facing from a reliability perspective?
So I think one of the key challenges which I have faced is, reliability is a very structured approach, right? How do you solve a problem in a structured way? We have tools, we have ammunitions, fishbone, 5 whys, 8D. We have all these templates, but when you are actually in a meeting with cross-functional teams, how do you bring them together to make them realize the value of solving a problem in a structured way? I think this is the challenge, the biggest challenge that I have faced. And some of the other challenges is, say, for example, conflicting goals, right? Say, for example, easiest example would be, say, say for a social platform, right? There could be one team's metric could be latency. They want the site to be available most of the time. But say another team's metric could be maximum number of new feature release. So you can imagine that if that team who is actually introducing a new feature there is a new feature which can increase the latency of the site of the social platform, then it is hampering the other team's goal. So similar things happen in all organizations, right? There are
Mm,
there are some teams like us is focused on increased product reliability, but there would be other teams who is focused on, say, um, cost savings,
right.
manufacture ease of manufacturability, operational ease, supply chain, sourcing. So how do you bring all of that together and manage the trade-offs in a way that the outcome is much more balanced? So that's,
Great.
I think, yeah, that's the biggest challenge.
Well, I feel like you're the perfect person to answer that question. How do you bring, because I think what you just described is the same challenge many people in reliability have, right? It's not necessarily the tools they have at their disposal or the data they have, but it's kind of the people problem of how do we recognize people have different incentives? Obviously, everyone's got the same big picture incentive, but based on the specific tasks or responsibilities they have, how have you found, what are some of the ways you've been able to accomplish that?
I think the the biggest ammunition resource we have in today's world is AI.
Hmm.
So essentially, the way I approach any problem is in a data-driven way. So as long as you have data, it can be from testing, it can be from actual field performance, and you do your homework in terms of correctly analyzing the data. Right now, we have so many tools, like, be it any AI packages, you have built-in programs which you can actually feed your data, making sure that you're following the company's guidelines, and then actually doing the analysis and going with that data. So always I have found that companies today's the particularly Bay Area companies, they are very data driven. And when you go with actually what the data storytelling, that's how we call it, right? When you tell the
Huh.
story using data, actually clearly showing that, hey, this is how we designed, this is what we promised when we designed, these are the key performance success metrics, these are the guardrail metrics, these were the trade-offs which we discussed, and hey, now 1 year down the line, this is where we are performing. Maybe it's performing great, so let's cut into production. Maybe it's not what we had discussed. So we should might be put a halt and then reevaluate our thinking. So always taking step back, doing proper like reliability analysis. I am a big fan of Jump. It's like a statistical tool, which is like my go-to. Say, for example, if I need
It's
to do
called
some quick
Jump, you said?
Jump, JMP.
Okay.
Yes, the reason I give this example is because I really want the listeners or the viewers of the podcast to, if they want, it's I think there is a 1 month free trial, and then you can actually
Yeah,
subscribe
that's
to it.
great.
It's great because it's like a go-to. Sometimes you might not have the time to run a complete code and do a complete automated analysis. So for a quick thing, if you have data, you can use some software packages. It's very similar to Meet app we used to use in colleges, but it's much for companies because it
That's
has
good.
many more capabilities. Yeah.
Great. I'm going to check it out. I wrote it down. So that was JAMP for anyone listening, just to check out a tool. And I did want to, yeah, it's always great to hear about new tools people are using. Our company is kind of specializes in root cause analysis. So I always like to ask people, how important is that in your process? And how are you using root cause analysis for uh, ensuring better reliability?
So that's a great question. And again, my fundamental approach to any root cause analysis is first to understand the scope of the problem. Because Pareto rule, right? 80-20 Pareto rule. It's 20% of your problems which will impact 80% of your performance.
Right.
That's always the case. So I always take a step back and then try to understand what is the scope of the problem. That's number one. Number two is what is the severity of the problem, because we cannot tackle all the problems at one go. So separate, divide, and conquer. So essentially, understanding what are the the top issues in terms of impacting product reliability. For me, when I say reliability, I'm only looking at expected performance over life. So that's how I evaluate any product, and because there is expected performance and there is expected life. So I want to make sure that we are achieving that over the life of the product.
Okay.
And if we have any issues, then after we identify, the issue is detected and these are the problems, this is the scope, this is the severity, then we kind of drill down. And some of the tools that I personally use is obviously 5Y fishbone. I find fishbone, it's 8D. 8D structure is a it's a phenomenal tool to bring all the teams together and you brainstorm. It can be fishbone, it can be mind map, it can be any other decision matrix, for example. But a structured way is very, very important, because then okay, so this is the overall arcing root cause. This is why this issue triggered. But then you go to the next level. Why? And then you go to, and if it's a fishbone, you can actually have all the sub bones. And then what I always do is, when I write something, I always back that up by data analysis. Either it could be from failure analysis data or it could be from performance data. And then I apply scores to make sure that we are documenting all the problems in a structured way, so that we can always come back and see that yes, we feel that the analysis is complete, and then we can move on to the next problem. And the other thing which I have found, Sebastian, is many times we are very thorough in root cause analysis, but then we found the problem. But then when we implement, say, a solution, we are not following through. What if the solution is like an immediate solution, but it might not hold after some point in time? So that's very important, that we actually are following through the solution. To see that it is actually rendering the promised improvement it was thought it will give when we implemented it.
It's good. Well, and I think given the types of products you work on, the kind of the hardware products, it probably is a tighter loop potentially, right? Feedback loop, because did that make the difference? So yeah, it's good. Well, it's just been great talking to you. I mean, I'm just sitting here thinking to myself, you would just do an amazing job, just with an audience, kind of just as your answers are so thorough as you walk us through. So I'm sure that's just so helpful in your roles, bringing people together to solve problems in structured ways. You clearly think in a structured way, but also clearly make people feel comfortable and easygoing. So I'm guessing that's kind of part of your skill, is just, you know your stuff in a logical way, but you also help bring people along. Just one final word, just kind of as we wrap up, what's kind of one thing about your expertise that you just think, I think other reliability engineers need to hear this? I mean, you've already given quite a few things, but maybe somebody you've described the cultures of your companies as, reliability is just built straight into the DNA. Maybe somebody who's not in that kind of an environment, what might be your advice to them?
I think for reliability engineers who are starting, they might think of this as an opportunity to make an impact to the product in a way that any reliability engineer can play a huge contribution in extending the product lifetime. So basically, they need to go beyond exploratory data analysis, right? So, okay, so you do an exploratory data analysis, you know what the problem is, whether it is performing good or not. But then what inferences or recommendations you give? I think that's very important. For young reliability engineers, I think they should go that extra mile, that extra stretch to interpret and draw inferences, observations from their data. What challenges did they face when they pulled the reliability analysis? It could be data mining challenges also, but documenting and going in a structured thinking approach to get that extra stretch, I think would be helpful.
That's great. Well, thank you. That's excellent advice. Well, thank you so much again. We've been having some time with Debasmita Mukherjee. Thank you so much, with Bloom Energy. She's just done a great job. And to everybody out there listening, the goal of this podcast is really just to help reliability engineers, and really anyone, just to take steps into practically accomplishing their goals and using applications. I love that you told us about a couple of tools that you use. We want to introduce people to new practical tools people are using to take steps. Of course, our company, our expertise is in RCA training, resources, and materials. I'd encourage you to check out reliability.com. If your company's looking to dig deeper into doing RCAs, or you can use our our reliability software, easyrca.com. But obviously, we're happy with all the tools people are using. Just want to make sure you know about those. Well, that's all we have today, folks. Thank you so much for joining. As always, we are on a mission to make the world a more reliable place, and we will see you next episode. Thanks so much again. Take care.